The moon has a stronger influence on Earth's tides than the sun because the moon is A, denser than the sun. The moon is denser than the sun, and that is because it is all solid versus the sun, which is made of gas. Or B, has more mass than the sun. The moon is much less massive than the sun. We orbit around the sun, so that would be incorrect. C, it is much closer to the Earth. The moon is much closer to the Earth. Or D, moves much faster relative to Earth. No, that is incorrect. Let's go back to C. C is much closer to Earth. As the moon is going to orbit around the Earth, the water on the Earth is going to move and be affected by the moon. So C is the best answer here. Which was the first object made by humans to orbit the Earth? And looking at this picture, the main idea you need to think about is which one came first. The least advanced objects had to have come first when you talk about any type of advancements. A and C appear to be the least amount of advancement, and then when you look down at B and D, these appear to have occurred much later after C and A. Correct answer here is C, Sputnik. Sputnik was launched in 1957 from the USSR, also known as Russia today. In 1957, this officially caused the space race to begin, which also caused NASA to form. The correct answer here is C. Why do regions of the world near the equator, 0 degrees latitude, which is right here, have a more consistent climate than regions of middle latitudes? In trying to answer this question, I want you guys to look at this picture over here. This is the sun, obviously not drawn to scale. We are much further away. I want you to look at the sunlight directly overhead versus the low angle of incoming sunlight on both the northern and southern poles. These direct or mostly direct sunlight rays right here are going to heat up these areas more consistently than our inconsistent rays of light up here. So we have our direct versus our indirect. Indirect is going to be more spread out. So the question here is essentially asking, why is this area in the center of our Earth around the equator more consistent? A lot of these answers over here really have nothing to do with this question. They have strong, moist, westerly prevailing winds. It doesn't really have anything to do with what we're talking about at the current moment. They have high averages of yearly rainfall. That really wouldn't do anything to keep this consistent. They get about the same amount of radiant energy year-round. Radiant would be radiation from the sun, so that sounds pretty good. Let's finish with D. They are close to large areas of very warm ocean water. Yes, but that's not going to cause this to be extremely consistent the entire time. The ocean will change the temperature, but that's not going to affect climates overall. Correct answer here is going to be C. They get the same amount of radiant energy year-round. No matter how the Earth is tilted, it's always going to get direct sunlight towards the center of the Earth. Basically between the Tropic of Cancer and the Tropic of Capricorn, it's going to be almost direct sunlight there versus the northern and the southern pole, which is 90 degrees north latitude and 90 degrees south latitude, will be very much of a indirect versus direct sunlight. The picture shows an infrared composite of the Earth as seen by a weather satellite system. What does the dark shaded area of the map represent? In order to look at this, first of all, infrared, that's going to represent heat signature. So let's look at this picture over here to kind of answer some of these basic questions. First of all objects in the solar system are going to be lit up by the sun by a total of 50%. Even though we're only seeing a small portion of the moon right here in a crescent form, it's still being lit up by a total of 50%. This is just our appearance. Now, let's look at the moon. This is our moon right here. Is it possible that the moon's shadow is going to take up this much space on both sides? No. If the moon's shadow is on the Earth, it's going to be a solar eclipse and it's going to be very small and moving quickly across the time. This question also asks thick cloud cover. Does that look like thick cloud cover? If it's this spread out, we would expect to see some over here. And this really doesn't make sense based off of what it's asking for infrared composite. Nighttime. Nighttime seems like a possible decent answer. As you see, about 50% would be day and about 50% would be nighttime. Now let's look at the last one, J, ocean currents. Does this seem to have any information whatsoever that deals with ocean currents? If it were only dealing with ocean currents, we should expect that it's only over the ocean, not over giant land masses. Correct answer here is nighttime. Which of these will cause the greatest high tides? In talking about the moon and how it affects the Earth, we notice that the moon is awfully close to the Earth, and as it revolves around, it's going to affect the tides. If you look at this picture over here that helps to explain it, you'll notice that depending upon where the moon is going to show where our tides actually represent. When they're in a straight line, we're going to have higher high tides and lower low tides. The gravitational pull from all of these three objects is consistent and not fighting each other. These are called spring tides. When you have them in a 90-degree angle, the gravitational pull is actually fighting each other. So there's going to be lower low tides and lower high tides. So the best answer here is going to be the one that is in a straight line, and that best answer is F. During which portion of the Earth's revolution around the Sun is the northern hemisphere tilted towards the Sun? Trying to answer this question, you want to look at the picture over here that really does a good job explaining how we're tilted and how we're affected by the Sun's direct and indirect rays. The northern hemisphere, tilted towards. So if we're tilted towards, then we're going to get direct sunlight coming at the northern hemisphere. In the northern hemisphere, when it is summertime, it's going to be winter time in the southern hemisphere. Correct time for this during our summer is called the summer solstice. It is when we have our highest amount of sunlight hitting the Earth in the northern hemisphere. We have our vernal, which is going to be our spring, where we have equal day and night. Our autumnal equinox, which is again equal. Autumnal is going to represent fall, and then our winter solstice. Winter solstice is right here. The northern hemisphere is tilted away. Majority of students might get confused as to why it is actually winter time in the northern hemisphere in our winter solstice. We are actually closer to the sun at this point. The main reason why, even though we're further away from the sun here and it's in our northern hemisphere, the summertime, is because we were tilted towards and getting direct sunlight. Whereas on this side, in the winter solstice, we are actually tilted away in the northern hemisphere, which gives us indirect sunlight, causing colder temperatures. Correct answer here is G, summer solstice. What is the approximate percentage of the Earth that is illuminated by the sun at any given time? This is a relatively easy question if we think logically about what it is asking. For instance, a couple of these are really bad answers. There's no chance that 90% of an object can be totally or almost totally lit up regardless of where the sun's rays are hitting. Right now, looking at this picture, it would appear as though the sun is directly hitting at this point right here, which means that these areas in the back are not being hit by the sun, and these are nighttime. Our rotation of the Earth actually causes night and day, and as we're rotating, only 50% of the Earth is going to be illuminated by the sun. When the Earth is at its greatest distance from the sun, its northern hemisphere is tilted towards the sun, as shown in the drawing. What season takes place in the southern hemisphere at this time? This question is actually asking you a couple basically different things at the same time. Sometimes with the larger amount of readings, it's easier just to read the last sentence to understand exactly what it's actually asking. Right now, it's asking what season takes place in the southern hemisphere at this time. So if the northern hemisphere is tilted towards the sun, we're going to get direct sunlight, which we've talked about a couple times in these videos and throughout the year. Direct sunlight is going to be more intense, and it's going to have more radiant energy or radiation, causing the northern hemisphere to heat up. So if this is the hottest time in the northern hemisphere, it is going to be summer, and it's asking what season takes place in the southern hemisphere at the time. If this area down here is now getting indirect sunlight, it's going to be the opposite of what's up here. And if this is summer, then down here has to be winter. The answer here is winter. Which diagram represents the placement of the sun, earth, and moon during a lunar eclipse? First of all, when we're talking about a lunar eclipse, we need to make sure that we understand what that represents. In this case, a lunar eclipse is going to be where we block out the moon, either fully or partially. In this location, we have the sun, the earth, and then the moon in a lunar eclipse. Which one of these is showing that the moon is actually behind the earth and is in the shadow of the earth? Right now, the only two where we see any type of shadow close to each other are these two. Unfortunately, this one is a lunar eclipse, so the best answer here is C. And this shadow here that is being placed on the earth represents a solar eclipse because we're blocking out the sun in this case. Again, a lunar eclipse is where we're going to partially or fully block out the moon from the earth. The penumbra is a partial darkness and an umbra is a total darkness. So again, a lunar eclipse is where we block out the moon because it's behind the shadow of the earth. These are not going to occur all the time or once a month because the moon is actually tilted 5 degrees compared to the plane of the rest of the objects in our solar system. So the correct answer is C. About how long does it take the Earth to make one complete rotation on its axis? Is it A, 1 day? It's a pretty good answer. Let's keep going through. Is it B, 1 week? Is it C, 1 month? Or is it D, 1 year? Okay, right now, we're left with really only A and D to think about. B and C really are bad questions here, and the only reason why I say 1 year is something we need to talk about is because sometimes students misconstrue what rotation or confuse rotation with revolution. Rotation is the amount of time that it takes the Earth or other objects to rotate one complete rotation, one complete spin around its axis. The Earth's axis is tilted at 23.5 degrees. Whereas our revolution, which is 1 year, is the amount of time that it takes the Earth to totally pass around the Sun, which is 365.25 days a year, which is a revolution. Or 1 day, which represents the amount of time that it takes the Earth to rotate on its axis at 23.5 degrees. If this were the vernal or the autumnal equinox, a day would represent 12 hours and a night would represent 12 hours. So 24 total hours for this rotation. Also, the Earth has 24 total time zones, which makes the best answer here A. The first manned mission to land on the moon was commanded by Neil Armstrong and was called, is it F, Apollo 11? It's a pretty good answer. Let's move on to the rest of them. Is it G, Gemini 3? Gemini was actually the second NASA manned mission program. The first manned mission program was Mercury, which is not on this list, but Mercury was the first mission that sent anyone up into space. Gemini was the second, which had 2 people aboard each ship, and Apollo actually had 3 people aboard each spaceship. Now, Viking and Mariner, these are both probes. Viking was sent to Mars along with the Mariner. Viking and Mariner both came before they were probes, whereas these two were both manned missions. The manned missions of Apollo 11 was actually the first manned mission to land on the moon in 1969. Neil Armstrong and Buzz Aldrin are normally the two that come to mind when you think about these groups. The southern hemisphere is warmer in January than in July because, is it experiencing summer? It might make sense if it's warmer then. The cold winds are concentrated in the northern hemisphere. Really doesn't make too much sense at the current moment. Let's keep looking through. The sun puts out more energy. The sun puts out the same amount of energy pretty much daily. It just depends on the amount of direct versus indirect sunlight, which we've talked about a couple times. Direct sunlight means that it's very intensified and very localized and it's not spread out. Or is it J, the hole in the ozone layer allows more heat into the atmosphere? The sun's rays are able to penetrate through the ozone layer regardless. That's not really part of this question at all. The southern hemisphere is warmer in January than in July because it is actually tilted towards receiving more direct sunlight. The picture here shows that the northern hemisphere is receiving direct sunlight. However, the question here is asking the southern hemisphere is warmer because it is experiencing summer. So the best answer here is F, experiencing summer, because the direct sunlight is hitting it. At what position would Earth be found in the solar system diagram found above? We all know that the sun is the center of our solar system. It's the most massive, most gravitationally bound. Mercury is the first planet closest to the sun, followed by Venus, and then there's this other planet that sits in here. Hopefully we all know that we are the third rock from the sun. At what position would Earth be found in the solar system above? Would it be in F1, which would be between Mercury and Venus? Probably not. Would it be 2? Would it be Mercury, Venus, Earth, then Mars? That sounds pretty good. Would it be H, which is 3, Mercury, Venus, Mars, or right here in 3 between Jupiter and Mars? There's actually something else already there. It's called the asteroid belt. Hypothetically, all these asteroids are considered a possible planet that never actually condensed together to form another planet. Or would it be J, which is number 4, which would be out here between Saturn and Uranus. These out here are the gas giants, all except for Pluto. Pluto is no longer considered a planet, despite what you might have learned at a younger age. It is now considered a dwarf planet. It does not consider to be a planet for a couple of various reasons. However, basically all of these planets out here are all made out of gas with the exception of Pluto. So our planet is actually an inner planet, terrestrial planet made of rock, primarily made of rock. And so we are 1, 2, and 3. So the best answer here would be H3. During which of these phases of the moon will the tides be the highest? So this question is asking what we've answered before during this time. At what location is the sun, earth, and the moon in a straight line? With the sun, earth, and moon in a straight line, the gravitational pull is going to be truly working together here. So you'll see, no matter whether it's a full moon or a new moon, the best option for the spring tide, which represents the higher high tides and the lower low tides, is going to represent just a better gravitational pull when they're in a straight line. When it's a 90-degree angle or anything else, the gravitational pull of the sun, the earth, and the moon are all fighting each other. So if we look over here, a full moon, that's right here. It's on the opposite side. So it's a sun, earth, moon relationship. During this time, we have a straight line. So that looks pretty good. Let's just see if there's any other questions or answers that look familiar and good. You have a quarter moon. It's going to be either the last or the first quarter. And again, these are in the 90-degree angles where they're fighting gravitation, and it's not the high tides or low tides. Crescent moon, same thing, and gibbous moon, also same thing. Neither one of these are in the same straight line like we talked about. Best answer here is A. It's going to be a straight line where gravitational pull is going to make the higher high tides and the lower low tides. Earth's axis of rotation is tilted 23.5 degrees relative to the plane of its orbit, which helps to cause, is it the seasons, which looks to be a pretty good answer. As you look over here, you'll see the Earth, which is blue, revolving around the sun. As it's revolving around the sun, it's also rotating on its axis at every 24 hours, which causes the day and night. The tilt of the axis does not cause the day and night. It's the rotation of the axis which causes day and night. As the Earth is revolving around the sun, you'll notice it appears as though the tilt is either tilted towards or tilted away, or basically right in the middle, which is the equinoxes, which are going to be equal day and night, but the northern hemisphere right here is tilted towards, which will give it more direct sunlight, which is going to cause the seasons. The lunar phases, there's nothing in this question that talks at all about lunar phases. Again, in dealing with high and low tides, we're going to talk about the moon. There's nothing here about the moon whatsoever. The best answer here is F, the season. Which of these are caused primarily by the gravitational force between the Earth and the Moon? Is it tides? Let's look over here and see. We've got our light pink, if you will, light purple. As the Moon is revolving around the Earth, we are able to see that this is starting to fluctuate. So we have our tides, and as they're changing, it's based off of where we're located. Seasons. There's nothing in here that talks about the seasons. As we've talked about before, the tilt of the Earth's axis at 23.5 degrees is really responsible for the seasons. This deals with our direct versus our indirect. Our prevailing winds really has nothing to do with this, along with our magnetic pole. So the best two answers that we even need to think about is going to be the tides and the seasons. And as we just talked about, the seasons only deals with the tilt of the Earth on its axis. So the best answer here is tides. Again, when they're in a straight line, 180 degrees, we know that they're in gravitational control. When it's 90 degrees tilt away, it's not going to be as strong. So the gravitational force of the Moon and the Earth is going to be more responsible for the tides. Best answer here is